Hello friends, in this video we are going to learn the next quantum number, that is magnetic quantum number. It is represented with the symbol ml. Let's understand this concept. So initially we have the principal quantum number. It is represented with the symbol n. Then we have the second quantum number. We called it as a azimuthal quantum number. It is represented with the symbol L. So it represents a shell, while the second represents a subshell. In that subshell, there is a presence of orbital. That orbitals are represented, or their orientation are represented with the values of ml. So you have to understand, in subshell there are orbitals, and that orbital's orientation can be represented using these ml values. These ml values are called as magnetic quantum number. Let's understand this concept using this image. From this image, we can say that for a given azimuthal quantum number L, the possible ml values ranges from plus L to minus L. In this case, these values 0, plus 1 to minus 1 and plus 2 to minus 2, these values indicates the values of magnetic quantum number, means ml values. Each ml values specifies the orientation of the orbital within a given subshell. So these values gives the subshell, and in that subshell these values 0, plus 1 to minus 1 and plus 2 to minus 2 values represents the magnetic quantum number values or orientation of an orbital. Let's understand the relation between azimuthal quantum number and magnetic quantum number. As we know, principal quantum number represented with the symbol n. The azimuthal quantum number can be calculated using this formula 0 to n minus 1. The possible ml values according to the formula plus L to minus L including 0 can be calculated. Total possible ml values for a given subshell can be calculated using this formula 2L plus 1. Let's understand the first shell. This first shell has azimuthal quantum number value 0. This value 0 comes from this formula. As we know, the value of n is equal to 1, and by adding these values 0 to 1 minus 1, it gives a value 0. The value 0 of azimuthal quantum number represents S subshell. The possible ml values can be calculated using this formula for this L is equal to 0. So as we know the formula, it ranges from plus L, it means from plus 0 to 0 to minus 0. But plus 0 and minus 0 is not considered the complete value. In this case, only 1, that is 0. Let's calculate the total possible ml values. As we know, in this case, the value of L is equal to 0. So L is equal to 0. By adding this value, L is equal to 0 in this equation, the equation becomes 2 into 0 plus 1. It gives value 1. Therefore, I have written this 1 value in this case. In this way, we can calculate the azimuthal quantum number values from values of n or principal quantum number. Similarly, the possible ml values can be calculated from the values of L, and the total possible ml values can be calculated from the value of L. Let's consider the principal quantum number having a value 2. For this n is equal to 2, there is a possibilities of these two azimuthal quantum numbers. These can be calculated using the formula 0 to n minus 1. So let's calculate. So in this case, as we know, the value of n is 2. Therefore, add this value 0 to 2 minus 1. It gives value 1. So only two values are possible. One is 0 and second one is 1. So these two values I have written here, 0 and 1. As we know, the 0 azimuthal quantum number represents S subshell and 1 azimuthal quantum number represents P subshell. Let's calculate the possible ML values. The possible ML values can be calculated using the formula plus L to minus L. In this case, as we know, the value of L is 0. So let's consider this first value 0. The possible ML values for every L is equal to 0 is only one value, that is 0. L is equal to 1. As I mentioned here, azimuthal quantum number L is equal to 1. For this L is equal to 1, according to this formula, the values ranges from the plus 1, as the value of L is 1. So plus 1, including 0. So 0, then minus 1. Let's calculate the total possible ML values. These values can be calculated using the formula 2L plus 1. So in this case, 2 in bracket, value of L in this case is 0. As mentioned here, L is equal to 0. Therefore, 0 plus 1 and its answer is 1. And for the second, having value L is equal to 1. So I write here 1 plus 1 is equal to 3. So these three are the possibilities, or anyone can directly write there is only one possibility. Therefore, I have written 1. And in this case, there are three possibilities, 1, 2 and 3. So therefore, I have written this 3. So in this way, anyone can write the answers of these values. Similarly, we can calculate the values of azimuthal quantum number and possible ML values for n is equal to 3. Similarly, we can calculate these values for n is equal to 4. So according to this formula, azimuthal quantum number ranges from 0 to n minus 1. So possible values are 0, 1, 2 and 3. We call azimuthal quantum number having value 0 as a S subshell, 1 as a P subshell, 2 as a D subshell and 3 as a F subshell. Then we can calculate the possible ML values according to the formula plus L to minus L including 0. The possible values are 0 for L is equal to 0. Then 1, it means the value starts from plus 1 to minus 1. These three values. For L is equal to 2, the value starts from according to this value of L. So plus 2, 2 minus 2, including these numbers. Similarly, for L is equal to 3, the value starts from 3 up to minus 3, including 0 and other values. The total possible ML values can be calculated using this formula by adding the values of L, or we can directly write using these numbers. So 1, total possible value 1. So there are 3 values possible for L is equal to 1. So total 3 values. Similarly, for L is equal to 2, there are 5 values and total values are 5. So we can verify these values using this technique. So for L is equal to 3, the values are 7. So second, third, fourth, fifth, sixth and 7. So 7th values are possible. Many times our teacher teaches us that S orbital can be written like this, P orbital can be written like this, D orbital like this and F orbital like this. So these values can be written at the top of these orbitals. So in this case only one value 0 is possible. So I have written 0. At the center I have written 0, then minus 1 and then plus 1. For the D subshell we can write 0 at the center, minus 1, minus 2, then plus 1 plus 2. This is the another way to represent these ml values. So for this case, plus 3, plus 2, plus 1, 0, minus 1, minus 2 and minus 3. This is the another way to represent the possible ml values. And we can say that s orbital has only one orbital, p orbital has 3 orbitals, d orbital has 5 orbitals and f orbitals has 7 orbitals. So these concepts are originated from these ml values. Let's understand the relationship between principal quantum number, azimuthal quantum number and magnetic quantum number. According to Bohr's atomic model, at the center there is a presence of nucleus. Around this nucleus there is a presence of shell. This first shell having principal quantum number 1 is called as K shell. Second is L shell and third one is M shell. Let's consider the M shell having principal quantum number n is equal to 3. Possible azimuthal quantum numbers can be calculated using this formula. The possible values are 0, 1 and 2. The value 0 represents S subshell, 1 represents P subshell and 2 represents D subshell. Then the possible ml values can be calculated using this formula plus L to minus L including 0. These subshells can be represented using this symbol also. So in this case the number 3 represents the value of principal quantum number. This 3 is common as these ml values belongs from the same shell. Therefore n is equal to 3. Therefore I have written 3. The first shell is S, therefore I have written 3S, then 3P and then 3D. So in this way anyone can write the subshell. So according to this formula, there is only one possible value of ml showing only one orbital for 3s. Then for 3p there are 3 orbitals and for 3d there are 5 orbitals. So anyone can write these orbitals on the basis of principal quantum number, azimuthal quantum number and magnetic quantum number. Thank you for watching this video.